Hi, my name is Asfa. For this individual assignment, I have choose Taiwan to test this estimation. For test unit root, as we can see, for ADF and PP tests, the new depth and the new case at level, we reject the null hypothesis, meaning that the data are stationary and significant at 5%, which is no unit root, while stringency index are only stationary and significance at 5% at first difference. While for KPSS, there is no stationary at level, so we do not reject the null hypothesis. There is stationary at first difference for new death and cases, means that they are significance at 5%, so we accept the null hypothesis as first difference. Next is JJ co-integration test. For Johansson co-integration test, the result shows for max eigenvalue and trace, at none and at most 2, the statistic value are greater than the critical value. We reject the null hypothesis, which indicates that there is one co-integrating vector or one long-run relationship in this model, while at most 1, the critical value are greater than statistic value, which means we not reject the null hypothesis. Therefore, there is one coin vector or one long run shape in this model. Next is VECM. From the ECT result, it shows that the coefficient of the error term in new death equation is statistically significant and negative. This means that the new cases contribute to the number of deaths. New cases and new deaths are significant at 5% level. The coefficient of new cases is 35.22. Hence, the adjustment will take 35.22% in a year to get back to equilibrium. Meanwhile, the coefficient of new death is 0.192. Hence, the adjustment would take 19.24% in a year to get back to equilibrium. Based on the condition of ECT and on the diagram above, it shows that there is one long-run significant relationship between which the new cases will affect the number of death equation. The coefficient of the error term for stringency index is positive. This indicates the stringency index does not contribute to explain the changes in new death. From Granger causality test above, we can conclude that there is no short-term significant relationship between new death, new cases, and stringency index. According to VECM, Granger's causality rejection rule, we reject the null hypothesis if the p-value is less than 5% significant level. Thus, we can conclude that new death Granger does not cause the new cases and stringency index. Therefore, this causality test shows that new death has long-run relationship and no short-run relationship in the equation. For variance decomposition test, based on the table, result shows that a shock in a new cases is highly affect in the new death in the long run compared to stringency index. Affect the new death are only show 0.2%. It means that the new cases are exhibiting strong indigenous influence on new death in the future, where new death is weakly endogenous influence on itself, which the percentage show it is decreasing in the future. The impact of a shock in the new death shows only 4% of forecast error variance in new cases, while stock intrinsic index also only shows small impact towards new cases. So both of new death and intrinsic index is exhibiting strong exogenous, which they have weak influence on predicting new cases in the future, while new cases are strongly endogenous, while they predict influence by 98% from itself. A shock in a new death and new cases show strongly exogenous, which implies weak influence on stringency index, while the stringency index is strongly endogenous by 99%, which implies strong influence from itself. Okay, the last one is impulse response functions. The observation or sample for this test is really big, but I only chose 80 days of responsive period to make a clear picture of the response. I have also tried different horizon length, which 100, 500, 800 and 1000 to see if there is any difference, and worry not because the result towards the end are not changing and constant. First off, the impulse response of new death to new cases and stringency index, the response toward the new cases is all positive and only fluctuated at the beginning of the days before continuing increasing and constant after the first 50 days. Response to the stringency index when negative at the beginning of the periods before it continues increasing till day 50 and when smooth constant after. Second is the impulse response of new cases to new death and stringency index. The response toward the new death fluctuated vigorously in positive and negative response of the first 10 days before it continued decrease toward negative till day 50 and when constant after. The response of stringency index is positive and negative, whereas when negative at first and bounce to positive, decrease a bit to negative before continue increase to till day 50 and when constant toward at the end. Lastly, the impulse response of stringency index towards new death and new cases, the response to the new death is all positive. Is increased at first and when constant for a while before day 10 and continue to increase till day 50 and when constant after. The response towards new cases is all at negative response. The trend started decrease from day 1 and fluctuated a bit before that day, day 10 before continue to decrease till day 50 and when constant after it. That's all for my test. Thank you.